We started this fun day in class today by having you guys figure out the pattern in each sequence. And then some of you came up to the board and wrote down the pattern. And in A, it was adding 3. And then in terms of writing it as a variable expression, it was n plus 3. In B, there were a couple of patterns some of you said. Some of you said you just add 5, which would be great because that is a pattern to get from 1 to 6, 6 to 11, 11 to 16. Somebody said every other number is adding 10, and that makes sense because 2 5s is 10. And other people noticed that the tens place is the same for 2 numbers in the sequence, and then it increases by 1. So the tens place in these two is 0. Then we have a 1 1, a 2 2, a 3 3, etc. And then the ones place is 1 6, 1 6, 1 6, 1 6, and that's another way to describe that pattern. And both of these we knew the numbers were getting bigger. So we talked about what kind of operations make whole numbers bigger, and it's usually addition, multiplication, or some combination thereof. So C, the numbers were getting smaller. And we talked about in class how usually when numbers get smaller, if we're dealing with whole numbers, there's either subtraction or division happening. And these get small pretty quickly, and then it slows down. So because it's got big gaps and then it slows down, you guys knew it wasn't subtraction. It has to be division. And so each one of these are being divided by 2. So we could say n over 2. And the next pattern, the numbers are increasing, but not by the same amount every time, but they are increasing by consecutive numbers. So first I add 1, then I add 2, then I add 3, so you had to add 4, add 5, add 6, and add 7. And the last one had several very cool patterns. To get from 1 to 4, if you're thinking addition, you could add 3. From 4 to 9, you add 5. From 9 to 7, you add 9 to 16, you add 7. 16 to 25, you add 9. So we talked about how you could be adding increasing consecutive numbers, but that wasn't nearly as efficient as seeing the multiply pattern, which is you just square consecutive numbers. So in other words, 1 is the answer to 1 squared. 2 is the answer to 2 squared. 3 is 3 squared. 9 is 3 squared. 16 is 4 squared. And remember, squaring a number means to multiply by itself. So if I see that pattern, I can get the next numbers really quickly because I know 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49, 8 times 8 is 64, etc. And then we also looked at these. If I put the square root symbol in front of each one, square root, square root, square root, it goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So really looking for patterns, and it really relates to Unit 2, which is all about using variables, and you can use variables to describe patterns. So next in your groups, you had to figure out which operation each word implies. And sum is the answer when you add. If I increase a number by something, I'm adding to it. We had a good discussion about this phrase, how many times bigger is 18 than 3? So if I were going to write an equation, I would use multiplication. But if I said, how would you find the answer to this? To solve it, you would divide 18 by 3 to get 6. If the word difference is used, that means the answer when you subtract. Product is the answer when you multiply. Quotient is the answer when you divide. 7 less than a number is subtraction. 7 increased by a number is addition. In means it gets bigger. A number decreased by 5 is subtraction. D means down, or to get lower. In means up, or to get bigger. So just talking about how do you translate English into mathematics, because the next thing we did was talk about different kinds of expressions. So numerical expressions you're all very familiar with. You've seen these problems since you were in first grade. 4 plus 7 is a numerical expression. It has numbers and symbols only to express an amount. And the numbers are usually, well, the numbers can be any kind of real number that you've dealt with, and the symbols are usually addition, subtraction, multiplication, or division. And then we move to algebraic expressions. And algebraic expressions have to have at least one variable. So the numbers, it can have numbers, but it has to have at least one variable. So 4 plus x is a variable expression. A number multiplied by 40, 40n, is a variable expression. So as long as there's at least one variable And here are some other examples. Like it can just be x by itself. That's a variable expression. I can have 3 variables, brackets, and 1 number. That's a variable expression or an algebraic expression. I can have 1 number and 1 variable. That's an algebraic expression. I can have a variable squared multiplied by a number. I can have 2 variables side by side. That means to multiply L times W, like length times width of a rectangle. And I can have a number with subtraction and a variable. These are all algebraic expressions, also called variable expressions because they have a variable. Okay, then we talked about how you have to be very careful with subtraction and division because they are not commutative. You cannot switch the order and have the same answer. So for EAL students, this can be quite difficult because of the English language having such subtleties. So I really tried to point out the key words for you today. So if we say in English 80 less than a number, the than is a key word. That means we start with a number and we're going to take away 80. So it would be n minus 80. And the way you can tell is that word than. 80 less than a number implies we begin with the number and we take away 80. And then I asked you, what's a real life situation with money in a bank? I have some money and I withdraw 80 euros. That would be an example of a real life situation. Okay, then I switched the words a little bit. 80 less a number. That simply means I took out the than. If I want 80 less a number, it's 80 minus a number. If this is money in the bank, that means I have 80 euros in the bank and I withdraw some money. You don't know how much, you just know it's some. This one has one small difference. 80 is less than a number. When I have is less than, that implies an inequality. So that means with money in the bank that I have $80, and some of you said if you're comparing it to someone else, I have $80 less than Angelo. Okay, and Angelo's money could be N. Or the amount of money I have in the bank, okay, is more than 80 euros. That's another way I could think about it. So be careful with division. They're not commutative. 8 divided by a number means 8 over n. So divided by means that that n is in the denominator. So if I had 8 billion euro and I were going to spread it out equally amongst the shareholders, my stockholders of my company, it would be 8 billion euro divided by the number of stockholders I have. Then we did some real life situations. If Max's allowance, A, is increased by 15 euros a month, I can write that as A plus 15. Increased by means I'm adding to it. And then I want to try to choose in real life problems a variable that helps me remember the meaning of the word. So I chose A because it represents Max's allowance. An allowance starts with an A. So that helps me remember what this problem is about. An allowance being increased by 15 euros. Okay, then we did this cooperative learning strategy or structure, heads together, heads apart. You had to listen orally. We did a lot of them just orally, and then we did some with your groups, but from the slate. So this one together was 6 times a number is increased by 5, and you guys did a great job with that, 6n plus 5. 18 is decreased by 4 times the number n, so 18 is decreased by 4n. And the sum of n and 5 is divided by 30, so you have to put n and 5 over the grouping symbol, divided by 30. And the product of 4 and a number less 3 is 4n minus 3. All right, and then we put everything together with our last lesson, which was using variables to describe patterns. So Kent has $120 in his savings account. He can save $5 per week from his allowance. And I wanted you to write an expression to show how much money he can save after W weeks. So to find this, I said think about just using numbers rather than W first. So in 1 week, he'll have $120 plus 1 group of 5. In 2 weeks, he'll have $120 plus 2 groups of 5. In 3 weeks, he'll have $120 plus 3 groups of 5. So in W weeks, he'll have $120 plus W groups of 5. And the way we write W groups of 5 is 5W. Remember, the number goes before the variable when you're multiplying in a variable expression or an algebraic expression. And then another last example, Stefan was swimming 400 meters daily as part of his training, and his goal is to increase that distance by 125 meters a month. And so I had to think about, in 1 month it would be 400 plus one group of 125. 2 months would be 400 plus two groups of 125. 3 months would be 400 plus three groups of 125. So M months would be 400 plus M groups of 125, or 125M. And for homework, you can either do the basic